colligative properties. What are colligative properties? Means the properties which depends on number of solute particles present in the solution are known as colligative properties. Means when you observe the solution, where the solution is having two components. So one is a solute, second one is the solvent. Where solute means it is in small portion. Okay, so small portion of a solution, or it is in less quantity in the solution. That solvent means large quantity. Okay, large portion of solution is known as a solvent. When you observe the properties of a solution, that properties are depends on the number of these solute particles present in the solution. Then that type of properties are known as colligative properties. Okay, అంటే ఏ ప్రాపర్టీస్ అయితే సొల్యూషన్లో ఉండేటటువంటి ఆ నంబర్ ఆఫ్ సొల్యూట్ పార్టికల్స్ పైన డిపెండ్ అయ్యి ఉంటాయో ఆ ప్రాపర్టీస్ని కొలిగేటివ్ ప్రాపర్టీస్ అంటారు. మరి అవేంటి? సో హియర్ దోస్ ఆర్, వన్ ఈజ్ relative lowering of vapor pressure. It is represented as RLVP. Now the second one is elevation of boiling point. Elevation of boiling point. Now the third one is depression of freezing point. Depression of freezing point. The fourth one is osmotic pressure. Okay, so these are four. One is relative lowering of vapor pressure, second one is elevation of boiling point, and third one is depression of freezing point. Last fourth one is osmotic pressure. Now we will see relative lowering of vapor pressure. Okay. First one is the relative lowering of vapor pressure. So ముందుగా రిలేటివ్ లోవరింగ్ ఆఫ్ వేపర్ ప్రెషర్ అంటే ఏంటని తెలుసుకున్నాం. ఫస్ట్ we will know about lowering of vapor pressure. It is represented as LVP. Lowering means decreasing, means తగ్గటం. Lowering of vapor pressure. For example, here a P0 is the vapor pressure of pure solvent. Okay, vapor pressure of pure solvent. Then after addition of non-volatile solute to the solvent form a solution. In the solution, the solvent vapor pressure simply we can call as a solution vapor pressure. So it is represented with P. Okay, so P means vapor pressure of solution. So lowering of vapor pressure means it is represented as delta P. We know delta means change in the pressure. Okay, so it is defined as the difference between the vapor pressure of pure solvent or pure component to the vapor pressure of the solution, means P. So the difference between the vapor pressure of a pure solvent to the solution vapor pressure is known as lowering of vapor pressure. Now RLVP means relative lowering of vapor pressure, means it is defined as the ratio between the lowering of vapor pressure to the vapor pressure of a pure solvent or pure component is known as relative lowering of vapor pressure. So when delta P means from the equation we should write P0 minus P by P0. Okay, P0 minus P by P0. So it is the relative lowering of vapor pressure. But actually, the Raoults is the scientist. He given the relation between the relative lowering of vapor pressure and the mole fraction of that component in the solution. Means mole fraction of a solvent in the solution. We will see that equation. So what is P naught here? Means pure solvent vapor pressure. Now we can represent that the pure solvent vapor pressure as P1 naught. Okay, P1 naught means pure solvent vapor pressure. Okay, pure solvent vapor pressure. Now here P means a solution vapor pressure or solution vapor pressure or the solvent vapor pressure in the solution. Okay, yeah. According to Raoult's law, we should write as where the vapor pressure of a component is directly proportional to its mole fraction in the solution. So P1 proportional to X1. But when we can remove the proportionality, we should write as P1 is equal to P1 naught into X1. Okay, so where X1 means mole fraction of a solvent. Okay, yeah. So we know lowering of vapor pressure. So lowering of vapor pressure is represented as delta P na. So delta P means simply for solvent we are representing 1 na. So delta P1. So where delta P1 is equal to P1 naught minus P1. Okay, P1 naught minus P1. But we know from the first equation P1 equal to P1 naught into X1. Then we substitute P1 here from first equation. Delta P1 equal to P1 naught minus P1 naught into X1. If P1 naught is common. So we can common that P1 naught value. Delta P1 equal to P1 naught into 1 minus X1. Here we know the relation means the sum of the all component mole fractions are always unity in the solution. Okay, here if the solution having two components, one is the solute, second one is the solvent, where X1 means mole fraction of a solvent. Okay, if we can say as X2 means mole fraction of a solute, then the sum of the mole fraction of all components are always unity, means it is equal to 1. We required 1 minus X1, then we shift X1 from here to there, we will get like X2 is equal to 1 minus X1. Then you write this X2 value here, what we get? Delta P1 is equal to P1 naught 1 minus X1 means X2 from this equation, where delta P1 means what we get? P1 naught minus P1. So P1 naught minus P1 by P1 naught is equal to X2. Okay, so here it is known as Raoult's law. It is called as Raoult's law because we got this equation from Raoult's law only. So what is Raoult's law? Means the relative lowering of vapor pressure. Relative lowering of vapor pressure of a solution which consists non-volatile solute is equal to the mole fraction of a solute, where X2 equal to mole fraction of solute na? So we should write mole fraction of solute equal to X2. Okay, we know mole fraction formula. So what it is, where X2 equal to the number of moles of solute by number of moles of solvent plus number of moles of solute, means N2 by N1 plus N2. Okay, yeah. For dilute solutions, so dilute solution means as compared with the solvent, where the solute is in less quantity. So for dilute solutions, we can neglect the N2 value in the denominator. So means N2 is very less as compared with N1. So means we can neglect N2 in denominator. Okay, so where x2 equal, what we should write, N2 by N1 plus N2 na. So we can neglect that N2 value in denominator, means N2 by N1. Okay, we can substitute that solute mole fraction in this Raoult's law equation. So means P1 naught minus P1 by P1 naught is equal to N2 by N1. But we know number of moles definition. So what it is, where number of moles means the ratio between the weight to the molar mass. Okay, yeah, we should write that equation that P1 naught minus P1 by P1 is equal to number of moles of solute, means weight of solute by molar mass of solute, into 1 by N1, means weight of solvent and molar mass of solvent. Okay, from this equation we required molar mass of solute. Okay, so where M2 means molar mass of solute is equal to, so just to shift that one, so where W2 into M1 into P1 by W1 into P1 naught minus P1. Okay, so what is M2? Means molar mass of solute. So where the equation is the relation between the molar mass of solute and the relative lowering of vapor pressure. So simply we should write like M2 is equal to W2 into M1 by W1 into P1 by P1 naught minus P1. So here P1 naught. Okay. It is a relative lowering of vapor pressure.